Welcome back, everyone. We're going to discuss the second paragraph of chapter 6 right now, which will be about calculations with the tangent, which we just were introduced to in 6.1, right? And maybe you remember that I said there that in the future we're going to call the rise and the run something different. Well, the future is right now. We're going to instead talk about a rise and a run, about so-called opposite sides, adjacent sides, which are new, well, the terms are new, not what they are, right? And the hypotenuse we already knew, that is in Dutch the schuine zijde. But let's take a look. If I take a look at the sides, and we're going to take a look at it from angle A, here's one side that is opposite to angle A. And this is called the opposite side. This is the side you can say that doesn't touch that angle. So here BC is called the opposite side, in Dutch called de overstaande rechthoekzijde. Rechthoekzijde, rechthoek zeggen ze daar ook nog bij. Because we're going to take a look at this as if this were always a right angle triangle, I should say. Well, then we have two sides left which both you can say touch angle A. One side is the hypotenuse of the right angle triangle. So that's the one that we're going to call the hypotenuse. And the other one we are going to call the adjacent side. And adjacent in Dutch means de aanliggende rechthoekzijde. And be careful, because you can say, well, the hypotenuse is also adjacent to angle A because it touches it, right? Yeah, but there's only one hypotenuse in a triangle that is right angled, and that is AC in this case. And the other one in this case is called the adjacent side. And here we're going to convert. Instead of saying rise divided by run, we're now going to use the formula right here, and this is the one that is commonly used when we're talking about well, now we're already kind of starting with trigonometry. Didn't call that out yet, but this is a very important formula in this chapter. The tangent of angle A is equal to the opposite side of angle A divided by the adjacent side of angle A. So it's important for you to recognize what is the opposite side of an angle, and what's the adjacent side of an angle. And that changes, right? If I take a look at angle C, then hopefully you now agree with me that this is now the adjacent side of angle C, and this is the opposite side of angle C. Now, hypotenuse stays the same. The hypotenuse doesn't change in a right angle triangle, right? How can we calculate anything with this? Well, we'll take a look at that later. I already kind of spoiled you. Here they say that this also works in not nicely vertical and horizontal triangles like this. So if you turn this triangle around, as maybe it doesn't really surprise you, it still works. And so, for example, if I take a look at angle P here, PQ is the hypotenuse. It's the longest side. It's the one that is opposite to the right angle. So what are now the opposite side and the adjacent sides? Well, the opposite side is right here. This is QR. And PR, the one that touches it, is right here. So here the tangent of angle P is QR divided by PR. And the tangent of angle Q will be the opposite side, which now is PR, divided by the adjacent side, which is QR. Right? And we can now use this to actually calculate with angles in triangles without any actual knowing all the information about the angles. We also did a lot of calculation with angles in chapter 2, right? But then we didn't really take a look at the lengths of the sides. Well, here we're going to use the actual lengths of the side to calculate angles. For example, here, in capital letters apparently, triangle ABC, angle C is 90 degrees, BC is 4.2, AC is 5.6, AB is 7. Which is funny because we didn't even really need 7 here, but we'll see that. How can we now calculate angle A and angle B? Well, first write down the actual formula with now numbers. Well, I shouldn't say numbers, but letters, and all the terminology changed into letters. So the tangent of angle A is the opposite side of angle A. Or what's the opposite side? That's this one, right? BC. Divided by the adjacent side. Be careful, the adjacent side is AC, not AB, because AB is the hypotenuse. So AC is the adjacent side. So we can now write down the tangent of angle A is 4.2 divided by 5.6. And I want you to write down this part in letters first. Certainly now we're doing this as a project, and I'm going to grade you on your intermediate steps, which I also do in the test, by the way, but certainly in your project, write this down. Write this intermediate step down. Please, it's for your own good. So if the tangent of angle A is 4.2 divided by 5.6, I can now calculate angle A as well by taking the inverse tangent. Right? You can say take the inverse tangent on both parts. The inverse tangent of a tangent cancel each other out. So angle A is the tangent, or the inverse tangent of 4.2 divided by 5.6, approximately equal to 36.9. Now you can calculate angle B using the tangent as well, by using the tangent of angle B equals the opposite side AC divided by the adjacent side BC. But maybe some of you who are also quite lazy, just as me, and I'm actually anxious to see what the book does, but I would just use the angle sum of a triangle here, and the book agrees. You can now just say angle B is equal to 180 minus 90 minus angle A, and you find what angle B is, because the sum of all the angles has to be 180 degrees in a triangle, as you all know by now. Okay. Oh, and I also see I made an error in my terminology here. I wrote adjacent when an E here. Please ignore that. I will change that later on. For now, just do as if there's an A here. I'm just a human being who makes mistakes. So adjacent with an A here, right? Just as here. Okay. And next theory, in theory B, we will discuss this in different scenarios. For now, practice this first using some exercises from your project. Good luck.